Good morning to all of you. Today, I will start with the non-linear ARDL model, and then we will go for vector auto regression model. So first of all, what is the utility of non-linear ARDL model? I downloaded a paper, and in fact, I find some of the papers where they focus on non-linearity of the relationship between dependent and independent variables. If you remember, we have two types of relationship in ARDL model. So this is dependent variable, and this dependent variable have two types of effect. Like for example, alpha plus beta 1, yt minus 1, and so on. So this portion, because after t minus 1, we will have t minus 2, t minus 3, t minus 4. This portion is known as auto regressive part. Then we have, let's say, gamma 1 xt. This gamma t is representing this gamma 1 representing short-term effect. Then we have gamma 2 xt minus 2 plus gamma 3 xt minus 3 and so on. So we call this portion as long-term effect. This long-term effect is also known as co-integrating relationship. And the combined effect of long-term and short-term, this is known as distributive lag model. Distributed lag. So in total, this model is known as auto-regressive and distributed lag model. Now the this concept we already studied. Now I am focusing mainly on this part. Long-term effect or co-integrating relationship. Research have found that this long-term effect is asymmetric. The long-term effect is asymmetric. So let me take only the long-term effect. Yt, this is AR plus DL, AR plus short-term effect, and plus we are having the long-term effect. Okay, I'm giving you one example. Suppose we are having the employment as a dependent variable, and you know that the employment depends upon the GDP. GDP is representing the status of the economy. Now think that GDP is going down. This is called negative impact. So when GDP is going down, you can imagine the time period of Corona when every company have a fear that the sale will decrease. So it was a psychological recession during the Corona period. It was a psychological recession. Every company was thinking that the demand will come down, the revenue will come down. Therefore, 90% of the companies, they start uh, they start removing the people, or they start decreasing the salary. So you have heard that that the salary is declining by 20%, 30% in almost every company. So every company reduces the number of employees. So this is the impact of negative movement of GDP. But when the GDP increases, whenever the GDP increases, the companies will not hire the people in the ratio they remove the people when GDP was going down. So the impact of positive GDP, positive movement of GDP is not similar to the negative impact. When GDP comes down, the retrenchment is very, very high. When GDP is going up, the appointment, the recruitment is not very high. So the impact of GDP on employment was not symmetric. The impact of negative movement of GDP is different on employment, and the impact of positive GDP is different on employment. So we can say that the distributive lag model is working differently, and especially the long-term effect, the impact of long-term effect. The long-term effect of X on Y was different, is different in positive movement of X and negative movement of X. So this concept is called asymmetric distributed lag or asymmetric long-term relationship. So this is the concept. In most of the cases, researchers assume that the effect of X on Y is not same when X is moving up, when X is going down. So in ARDL model, this is called non-linear ARDL model. So when you feel that in my case, maybe X is having the asymmetric effect on Y, then you can go for an ADL model. And I believe that whenever you are applying ARDL model in the paper, always check whether the asymmetric effect is there or not. So this is the concept of NADL model. And previously, in last session, I was trying to run the NADL model, but R was not working properly. But today I checked later on, and now it is properly working. I am showing you how to run it in R. In eViews, we can also run it, but in very latest version of eViews, because in latest version of eView, they are having the eViews add-ins. So in eViews add-ins, you are having one of the add-in called non-linear ARDL model. But let me show in R. So I am using these packages. After that, I'm going to apply an ADL model. The data I'm using is Ford. The data you can see by typing the name of the data set. We are having two variables here, food and INF. If we type head, we can see the top 6 observations. Head is showing you top 6 observation in the data set. So data set is started from 1962, and tail will show you the last 6 observation of the data set. So we are having the data up to 2015. And how many observations we have? Length means number of observations. So 54 observations we have from 1962 to 2015. In time series, we have to check what is the nature of the variables. So you can see that nature of the variables is numeric, so we can work on it. In case if it is showing you factor, then you cannot apply any of the technique. Then we are attaching the data so that we can work on the variables. Okay. Now there are 3 cases of NADL model I'm running. The example 1 is when your P and Q is similar. P is the number of AR terms and Q is the number of DL, the lagged variable of the independent variable. So in this case, I am running the regression number 1. Function is NARDL model, NARDL, dependent variable followed by independent variable. Now here I am telling you we cannot add 2 independent variables in the model. You can apply an NADL model only with 2 variables, one dependent and one independent. So this is the limitation. Here AR are 4, AR values are 4, DL are also 4, data is Ford, and the Akaike information criteria is used. Maximum lags is false. We are taking fixed values. Graph is equal to true, case is equal to 3. Okay. So this is the format of the model. And I'm running it. And so this is the result. Actually, the software give you so many results. So number 1, the software is showing you if you select 4 lakhs, this is the AIC value, this is the BIC value, and both the values are lowest. 246 value is the lowest in the 4 lakh. 278 is the lowest in the BIC, Beiser information criteria, and R square is 48 with 4th lakh, and log likelihood is minus 106. So lowest it is, better it is. So then we are having the NARDL model. It is simple model, like we calculated in ARDL. And whether the long-term relationship is significant or not, it is significant. A value is found to be significant. The Jacob-Miller test is showing you the distribution is normal. The distribution of the residuals is normal. LM test is showing you the autocorrelation problem is not there because it is p-value is more than 0.05. Arch test, which is showing you the whether the AR term is significant in residuals, or basically this is called clustering of the residuals. It is not significant. So the model is fine. There is no problem in the model. Long-term coefficients, or that you call bound test, and software also showing you the non-linear asymmetric effect. As I told you, that this asymmetric effect we checked in the long term. So in the last, you will get this value, the long run asymmetric test, and it is showing you no effect. Because the p-value is 0.14, it means there is no asymmetric value, there is no asymmetric distributed lag, or there is no asymmetric long-term effect in the variables. So we concluded with this. Now we are having another case, because in first case we defined the lag, that p equal to 4 and q is equal to 4. Suppose we say that let's software select the lag automatically. So in example 2, we are having auto selected lags. Maximum lag is true on the basis of Akaike information criteria. So we put maximum lag is equal to 2, means the number of lags are selected by the software. We are not selecting the lag as we selected in case of p is equal to q, q is equal to 4. Because maximum lag we put false. It means we are restricting the software to find out the lags. Here we are saying that, okay, no problem, lag will be selected by the software. So now I am going to run the regression model 2, where lags are selected by the software. So let's run it. And let me show you the results. Yeah. So summary regression 2. The software is selecting the lag 3. And this is the ARDL model. The model is significant. And model diagnostic, because all the diagnostic you have to report it in the paper. So this is the values of Jacobi test, LM test, Arch test, all are good, no problem. And this is the long-term effect which you have to report in the paper, and asymmetric effect is found to be significant. So long-term asymmetric effect is found to be significant. So you can say there is a asymmetric effect. There is a asymmetric effect on the dependent variable. So it means that the distributed lag or long-term effect from X on Y is asymmetric. So this is the result we can show in the paper, that in this case, the long-term effect is asymmetric. So we should not apply ARDL model, rather we apply NADR model. And after that, you can report the graph. Okay, so graph. But NADL model is, in this way we can apply an ARDL model. So check, I think graph will definitely come. So here, from here you can plot Kusum plot. So in my software there is problem, otherwise it will work. So in this way we can apply the non-linear ARDL model. After understanding the non-linear ARDL model, now we are moving to the extension or the substitute of ARDL model, that is known as vector auto regression model. The difference between ARDL and vector auto regression model is that there are two basic differences. If I explain you the difference, two major differences exist between the two terms ARDL and VAR. So ARDL is applicable when the dependent and independent variables, they have different order of integration. In that case, ARDL is also applied. In VAR, the condition is that same order of integration. You can apply VAR only when the dependent and independent variables have same order of integration. Means they are stationary on the same difference. Number two, you can study the short-term effect and long-term effect. So here we are, the short-term effect is not there, only the causality. So we call it causality, causal, no short-term. So only causality we can study in VAR. Number three, you take the variables at level. When you apply ARDL model, in VAR you have to take only transformed variable. Only transformed variables can be taken in case of VAR. You cannot take the variables at level. So these are the three basic differences between the ARDL and the VAR. Now we are shifting to the vector auto regression model, and I will complete this with the help of EViews today. So basic concept we will understand in EViews. So let me explain you the VAR first, and then I will show you the PPT and all. So today is 7th week, and we will cover the vector auto regression model in this week. This vector auto regression model is known as multivariate causality. I hope you can see this slide. The bivariate causality we have already finished by using Granger causality and Toda-Yamamoto test. Now we are moving to the multivariate causality. So as the term multivariate means there are more than two variables. When there are only two variables, we call it bivariate, and when we have multiple variables, this is called multivariate causality. More than two variables. All must be stationary. All must have same level of integration. And we are interested on not only to study the short term, but the causality between them. Then we apply vector auto regression model. So multivariate causality between financial time series using VAR. And why it is called vector auto regression model? Because The VAR system, it is actually a system of metrics. When we assume that all variables are endogenous. In vector order regression model, we assume that all variables are endogenous. And we assume each variable as a dependent variable and each variable as a independent variable. And the system, the VAR system, is represented by this. So this system, first of all, I will explain the system, then we will move to the next slide. So multivariate causality can be plotted like this. Okay. Before moving to the steps, let me explain one more thing. Yeah. So as I told you that there are more than two variables in the VAR system. Suppose we are having three variables. So let me call them xt, yt, and zt. And we believe that every variable is endogenous. So we can write three equations here. The first equation is assuming xt as a dependent variable. The second equation is yt as a dependent variable. And third equation we assume as zt as a dependent variable. And all the variables have the same right hand side. So I am writing only once. So this is similar for all the dependent variables. So first of all, I am taking alpha plus beta 1 x t minus 1 plus beta 2 x t minus 2. It is the past values of x plus gamma 1 y t minus 1 plus gamma 2 y t minus 2 gamma 3 t y t minus 3 and so on. So these are the past values of y plus delta 1 zt minus 1 plus delta 2 zt minus 2 and so on. So this term is similar for this equation, this equation, this equation. So the right hand side is similar plus the error term. So we have three equations. The right hand side of all the equations are similar, and we can put this system in the format of matrix algebra. So how we mention the how we write the matrix algebra, so that I am just showing you. It is not very difficult. So first of all, let me write all the three equations separately. Now, this is alpha 1, this is alpha 2, and this is alpha 3. Then beta 1, 1. So we will write 1, 1, 1, 2 like that. xt minus 1, previous past equation. Gamma 1 yt minus 1. Gamma 2 zt minus 1 and e1. Similarly, beta 2, 1. Then x t minus 1 and so on. Then gamma 2, 1, yt minus 1 and so on. Plus, suppose this is delta 2, 1, zt minus 1 and so on. Similarly, we can write beta 3, 1, xt minus 1 and so on. So in this way, there are three equations. So these three equations can be converted into algebra, matrix algebra. So the right hand side, we will take this. Then we will take the constant. And this term, this portion, we have to represent the product of the two matrices. And finally, we have to take the error terms. So this whole system is represented like I'm showing you how it is looks like. So this system is looking like this. Let me play slide show. Now, in this equation, in this system of VAR, we are having four variables, four coefficients, and these are the coefficients of the lagged values and the error terms. So this system is known as vector auto-regression model. So we assume that each variable depends on its own past values as well as the past values of other independent variables. So this system is called vector auto-regression model. Now, how to run the VAR? Because I have seen so many confusions when the scholars are applying the VAR. So to make the concept simpler, I make these steps. If you apply the VAR according to these steps, the things will be very, very easy and scientifically, and it will be correct. So I'm showing you how to apply the VAR systematically. So there are 8 steps which we will discuss. So the first step is identify the time series variables. So normally we have 3 or more than 3 variables in the vector auto-regression model. So first you need to identify. So selected time series variable should have the same order of integration as we discussed. The variables which you included in the VAR system must be stationary. It means you are including the transformed variable in the model. And there must be some logical cause and effect relationship between the variables. Otherwise, you cannot explain why one variable is causing other. So this is the first step. And the first step, the equation are represented like this. This is just an example that 3 variables can be written, because when you write the model in the paper, you have to write like this. T minus I means I lag of PCE, J lag of PDI, M lag of GDP, like that. Now the second step. After identifying the model, this is very, very important step, and researchers avoid this step in most of the cases. The ordering of the variable. Ordering means sequence. If you keep the sequence like if you keep this sequence x, y, z, y, x, z, z, y, x, so each sequence will give you the different results. So this is a problem in vector auto-regression model. The sequence is very important. If you change the sequence of the variables, the result will be different. Especially 2 results will be different, that is IRF result and VD result. IRF stands for impulse response function, and VD stands for variance decomposition. So these 2 results will be different. So right sequencing is very, very important. So the question is, what should be the right sequencing in VAR? So I have asked this question to many professors that how you deal with the right sequencing. So there are few methods which they told me. So the method I'm going to explain. So sequencing of the variables in VAR system influences the result of impulse response and variance decomposition. It is suggested, because it is mentioned in many books and papers, that you have to keep the sequence in the order of decreasing exogeneity. Means most exogenous variable should come first. Least exogenous variable should come in the last. So we have to remember that the decreasing exogeneity sequence we have to adopt. Now the question is that how we decide this exogeneity? On what basis we can say this variable is most exogenous, this variable is less exogenous? So there are many ways of this. Number one, you can find out by the chi-square value, or you can find out by r-square value. Both will tell you that which variable is most exogenous. High, so least is the value most exogenous will be. If the variable is having the highest r square or more larger r square, it means that variable is endogenous, not exogenous, endogenous, because that variable can be explained by other variables. So here I suggest you two things. You can find out the exogenous variables by looking at their r square values or the chi-square values and arrange them in the order of decreasing exogeneity. So this is the most important step in vector auto regression model. Otherwise, you will get the wrong result, and reporting the wrong result is not a good thing. So the second step is to find out the right sequence of the variable and use this sequence in the VAR system. Then we have the so this paragraph I took from the net. So just have a read on this. If you are going to use a Cholesky decomposition in order to realize your impulse response function, then you need to take care of the order. Order means sequence of the variable. The idea is that when you do the Cholesky, you have an lower triangular matrix or a upper triangular matrix, because in vector auto regression model, every calculation is based on matrix algebra. In matrix algebra, you know that there is a diagonal in between, and the lower part is known as lower triangular matrix and the upper part is known as upper triangular matrix. Like if I show you, if this is a matrix, this is the diagonal, this is called lower triangular matrix and upper triangular matrix. So this upper and lower triangular matrix will change if you change the order of the variable. So in the lower triangular case, you need to order with an exogeneity criteria. It is put first the most exogenous of your variable, then the second, on until you put last the variable for which all the variable have effect on it. It means in the last you have to keep most endogenous variable in the equation. So this is the suggestion given by the authors, and it is because EViews is software which works on lower triangular matrix. So it is doing calculation on the lower triangular matrix. So the sequencing is very, very important, and we have to follow the sequencing in the decreasing order of exogeneity. And then the third step. So once you identify the right order, then go for lag selection. Now, many people ask me that what is the right method of lag selection? And in fact, I have not seen in any book that this method is best, this method is best, or this method is best. And even in some cases, we adopt SIC criteria, squads information criteria. In some paper, we take the Hannan-Quinn criteria. I have seen that some papers are considering the AIC criteria also. So the question is that there is no best one. No criteria is a best criteria. And even if you have daily data, the results are different. If you have monthly data, the criteria will give you another problem. In daily data, most of the criteria give you very different results. In daily data set, Akaige information criteria sometimes take you to the lag of 36, which is very large. And it is just impossible to take the lag of 36 even in daily data. In monthly data, sometimes AIC take you to the 12, 13. So AIC is giving you the maximum number of lags. And squads criteria is giving you the shortest number of lags. So ideally, we have one thing in our mind, that in daily data, we should not go beyond 6 and 7. Beyond 5, it is just impossible to take the lags. Because why? Because in daily data, anything which happened in the past 5 days back may not influence today. It is absorbed in 5 days. And in monthly data, 4 or 5 months are fine. Up to 12 you can go, but beyond 12 you can also not go. So sometimes we have to use our mind that which lag selection criteria need to be adopted. What one thing which is common in all criteria is that you have to choose that lag which removes the problem of serial autocorrelation. So the purpose of choosing optimal lag is to reduce the problem of residual correlation. So this is the most important thing. The key point is the removal of serial correlation from the error terms. So there are several criteria for choosing the optimal lag length in the time series: AIC, Akaike information criteria, BIC, squads information criteria, Hannan-Quinn criteria, root mean squared error. So there are many criteria. So we will see how we can remove it. Now, the fourth part is that once you apply the optimum lag in the model, then you have to apply the block axonomy test. Block axonomy test is the most important test in the VAR system. And in every research paper based on VAR, you will see the VAR result. So vector auto regression model is incomplete if you don't report the WALD test. The WALD test is based on chi-square test, and the null hypothesis is that we cannot exclude this variable from the VAR system. And if the p-value is insignificant, it means the variable is significant. So WALD test can tell you which variables are contributing something significant. Which variable, or in simple words, there is a significant causality in the direction of X on Y. So this hypothesis can be examined with the help of block axonomy test. And why it is called block axonomy? Means after controlling the other variables, because this controlling effect was missing in Granger causality and Tota-Yamamoto test. We cannot control other variables. So this is the limitation of those tests. But here we are having the advantage that we can control all other exogenous variables and find out the impact of X on Y. So like I'm just showing you the sample. Suppose we are having xt, yt, and zt. The VAR test will show you the result. Suppose xt is the dependent, yt and zt, and their chi-square value will come. And this is p value 0.01 and 0.05, let's say. So we can say that controlling the zt, yt is having a significant effect on xt because probability value is less than 0.05. But in case of zt, controlling the y, zt is not having impact on x because the p value is more than 0.05. So the controlling effect is automatically coming in the Wald test. So we have the controlling effect in the vector order regression model, and this controlling effect will give you the more accurate result in multivariate causality system. So if Wald test for a variable is significant, you should include that variable in the model, else remove it. So this is the meaning of the Wald test. It is the most important table of vector order regression model, need to be reported in the paper, and will tell you the exact causality in the system. After that, after applying the VAR, now you have to apply the impulse response function. Impulse response function is, I have seen many graph of impulse response function in the papers. So I suggest you to take this impulse response function, paste in the paper. It is a graphical format of representing the causality from one variable to another variable. Now, even the impulse response function is misunderstood in most of the cases. So let me explain what is the meaning of impulse response. So let's say impulse means a shock. Impulse means a shock. Suppose we are interested in finding out the causality between US market and India market. Suppose some unexpected news comes in US, and because of that, there is a movement in the US market. So if US market is have a unexpected movement, so we call it that there is a shock comes in the US market. Shock means a new news or a unexpected information or a shock. It is also called innovation. So when a new information comes in one market, that market is obviously respond to it. Now the question is that how other market, let's say India, how other market respond to US market. So that is called impulse response function. How one variable respond to unexpected shock in other market. So that is called impulse response function. It may be possible that this response is positive, or it may be possible that this response is negative. If the response is coming like I'm plotting a sample response, this is a graph. In this graph, this is period or lag, and this is the response. So this is lag 0. This is basically lag 0 comes here, lag 1, lag 2, and that's it. Okay, so on the same day, suppose the starting point is this. It means on the same day, the impulse is positive, and it come down to second day, next day come down, and die in the third day. So the graph is moving like this. So highest on the first same day, moving down on the second day, it means lag 1, and move down after 2 days, and after 3 days it is die. So this is the response. and this response is positive because it is above the x-axis. Similarly, if you have this kind of response, it means it is negative, significant negative response. In some cases, the response may be positive. In some cases, response may be negative. So, and there are two types of responses: accumulated responses and the normal responses. In some cases, I have seen the accumulated responses. Accumulated responses means this is the response on the first day, second day, third day, fourth day, and after that it dies. So this time period is the period when Y variable responding to the unexpected shock in other market, and after this lag it will die. So this is the time period of the response of one market on another market. So normally we have seen that maximum 11 days. After 11 days, in most of the cases, the shock will die. In some cases, it is normally 3 days, 4 days, 5 days. So we can find out the short-term effects and the long-term effects of the shock on the response. So the impulse response function is a graphical representation of the causality between the two variables. And there are many different definitions of impulse response function. Basically, the impulse response is a word which comes from the physics. If you see the definition of impulse response, they will give you the definition which is coming from the physics or the electronics. But when we apply this concept in finance, it is the response of one variable to the unexpected shock comes in another variable. So that is the called impulse response function. The another thing which is important here, there are two types of responses: Cholesky responses and the generalized responses. So you have to keep in your mind that, so I have to write here, so we are having Cholesky versus generalized. So there are two options of running the impulse response function. So we should always click on generalized, so that if any effect comes from the ordering, the effect will die. So to remove the effect of ordering, if any, we should kill that. We should remove the ordering effect by selecting the generalized responses. And otherwise you can find out the normal, accumulated, for less number of period, more number of periods. So there are many options we have in impulse response function. So I will show you in the EViews. After the looking at the impulse response function, and this also go in the research paper, then we move to another important term, which is known as variance decomposition. Variance decomposition, there are two meanings of variance decomposition. Number one, this is decomposition. Decomposition of what? Decomposition of the variance. Variance of whom? Kiska variance? Variance of the error term. So variance decomposition explains the decomposition of the variance of the error forecast. So it will tell you that how many proportion of variance of a variable explained by other variables. So we can plot the variance decomposition function by making some graphs. Otherwise, if I make a pie chart, like we are decomposing the variance. This is 100% variance. Let's say 50% variance is coming because of its own lag. The 30% variance is coming from x1, 20% from X2, 5% from X3, and 5% from X4. So something like that. So we are explaining that how much proportion of the variance in the dependent variable can be explained by different independent variables. So by definition, let's see. The variance decomposition indicates the amount of information each variable contribute to other variable in the autoregression. It determines how much of the forecast error variance of each of the variable can be explained by exogenous shocks to other variables. It also helps to determine the proportion of variance of the dependent variable explained by each of the independent variables. Variance decomposition enables you to determine how much of the variability in dependent variable is lagged by its own variance. So in simple language, if any change comes in one variable, so what is the proportion of the explanation from different variables can be studied by variance decomposition. Means कि कौन सा वेरिएबल बाकी वेरिएबल से कितना कितना इन्फ्लुएंस हो रहा है, that is the called variance decomposition. Okay, now I think these are the steps. After that, we do the forecast and validation of the model. So this I will show you, and now I'm going to show you each step, how we can do each step with the help of example. So I will keep this page on, but I remember it, so I will move step by step. So now I'm going to the view software. So I am opening a file, feedback, in which I have three important series: the FII equity investment, mutual fund equity investment, and the Nifty index. Where foreign FII is a stationary series. If I check it, it is found to be stationary. The mutual fund equity investment found to be stationary. And if I take the log of Nifty, so I'm taking the log of Nifty index, and this is log of Nifty. It is found to be non-stationary at level, but when I do on first difference, it becomes stationary. Okay, so this is one thing, and actually the problem here is that their I0, it is I0, and Nifty index is I1. So according to the rule, I should not go for the VAR model because they have different order of integration. In this case, I should go for ARDL model. But normally, I have another way to do it. Like we have equity purchase, we have equity sales. So I can make a variable. This is simple FII equal to, I'm taking the ratio of purchase to sales. So FII equity purchase norm divided by, so why I cannot take the log, because they have negative values. So just taking the ratio. So I am taking the ratio of the variable name is FII is equal to FI equity purchase upon FI equity sales. This is the variable. Similarly, let me take mutual fund equal to mutual fund equity purchase divided by mutual fund equity sales. Okay, some variable is having, okay. Now I'm taking FIA mutual fund and log on Nifty equal open as a group. So we have these three variables. And first of all, log of Nifty. I am opening them as a VAR. So when you apply as a VAR, you have to select the variables to be included in the time series. Apply the vector or regression model. And you need to take the D log difference, first difference of the log, because it is non-stationary. So we have to take the transformed variable. And FIA mutual fund I'm taking as it is because they are stationary, although ARDL is a better model here, but let's see what we can have the result in VAR. Mutual fund, FI, D log Nifty, all are stationary values. Click OK. Now we are having the result. The second step is to identify the order of sequence, order of the variables. If I take the R square, this is 5%, 9%, 1%. So Nifty should come in the first, this second, and this third. According to the ordering, Nifty is most exogenous. So I cut it and put here. Because it is most exogenous. Let's see again. So the least R square should come first, then increasing R square. So R square of each variable should be more than the previous one. So this is the simple case of ordering of the variables. And we have to recheck it also. So the second step of VAR is to identify the sequence, the identification of the proper sequence. After that, we can go for lag selection. So this is the step of identifying the best lag. By default, it is taking 8. You can convert into 12. Okay. So you can see that the squads criteria is selecting the lag 3. Hannan-Quinn criteria is selecting the lag 4. And because of this star, you can see this star. In Hannan-Quinn, it is 4. In squads, it is 3. And it is 9 in case of AIC. So in daily data, we never go for AIC. So we have to check at 3 and as well as 4. So let's take the 4. Okay. And we have to check whether it is similar or not. Yeah, it is 1.3, 6.6 and 10.7. To find order is still same. Then you can check few tests, like you can check the AR root graph. All dots should be within the circle. That is fine. In residual test, LM test, so in daily data, it is creating a problem. So we can see a lot of significant autocorrelations. And okay, so if we increase the lag to 8 lag, so we have to check what effect it comes on the autocorrelation problem. So it is very highly significant. Okay. So how many legs we are taking? We are taking the leg of 5. So then we have to go for block axonality test, Granger causality block axonality test. So this test is known as VAR test. So after identifying the optimum leg according to the leg length criteria, which is representing by 4, and you can cross check it by clicking on leg exclusion test. It is significant. 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 So the software is saying that 5 lag is significant. Even we can increase to 6. Even 6 is also significant. So selecting the lag is a problem in VAR, and we have to do it very cautiously. After looking all the things, we have to finalize a lag system. It's still significant. And if I go for 8, yeah, you can see that here it is insignificant. So you can take the lag up to 6. The moment you take 8th lag, it becomes insignificant. So selecting the lag is a problem which you have to solve very cautiously, that how many lag we should select. In research paper, we don't do these much test. We simply go to the lag structure, lag length criteria, and say that Hanen Quinn is suggesting 4, so we take 4 lags. And I will also show you one paper which is published in Global Business Review. And in this paper, it is my paper on the same data set which I am showing you. So you can see that this is a selection of lag length, and we have reported that Squad's information criteria is suggesting the 4th lag. So we go for 4th. In this way, we reported that how many. In most of the paper, they either follow Squad's criteria or Hanen-Quinn criteria. So 4 lag. Okay. Now, so 4 lag. After that, once you define your lag, then you have to go for VAR test. The VAR test, this is the table which you need to report in the paper. And the result is that Nifty is caused by FII and mutual fund in 4 days significantly. FII is not caused by mutual fund, but it is caused by Nifty. Mutual fund is also not caused by FII, but it is caused by the Nifty. So we can say that the Nifty is caused by both, because both are the investors, big investors. And mutual fund and FI are not causing each other, but they are caused by the market. So this table you need to report in the paper. The simple explanation is that which variable is caused by which independent variable. All variables comes one by one. After that, you go to the impulse. And in impulse, we are having many options. First of all, I have to see simple response for leg 6, let's say, and multiple graph. In impulse definition, go for generalized impulses to remove the ordering problem. And this is the response. In this response, we don't need to check Nifty to Nifty. The diagonal we need to remove. Okay, now we are having all other. This is insignificant, so I'm removing it. This is also insignificant. Mutual fund to FI is also insignificant. Okay, now we have to report these graphs. And one thing which I'm showing you, which is our main conclusion, when we see the response of FII to the Nifty, it is positive. And when we see the response of mutual fund to Nifty, it is negative. It is negative. So what it means? It means that Nifty, if Nifty is moving up, FII are buying. When Nifty is moving down, they are selling. So positive response in the same direction, response is coming in the same direction. It means when the Nifty is moving up, FI start buying, and when the Nifty is moving down, they start selling. This kind of trading is known as momentum trading. Momentum trading behavior, or this is also known as trend chasing behavior. If the trend is positive, buy. If the trend is negative, sell. So FIIs are involved in trend chasing behavior or a momentum trading behavior. But if you see the mutual funds, if the market is going down on the same day, they sell. But when the market is going down, after that, they start buying. So in the moving down market, they buy. And if the market is moving up, they sell. So they immediately changes their position according to the market movement. If today market is down, next day they will buy. If the market is up, next day they will sell. So this is called profit booking or value trading. Value trading means when the market is over valued, it is sell. When market is undervalued, it is buy. So the conclusion we draw from this data set is that the FIIs are involved in momentum trading, and mutual funds are involved in contrarian trading or value trading, like that. So impulse response is showing you the direction of the response to the another market. So we can make different type of graphs, like if I take accumulated response and let me click 50. So you can get this accumulated response. Sometimes this graph is also fine. Let me show you this some graph. Let me delete this. Okay. This we need to delete. And mutual fund to mutual fund also. Now you can see this is the FII to Nifty, highly positive. Accumulated response of mutual fund to Nifty, highly negative. So even you have this kind of result, you can publish it. So let me, this is the Nifty to mutual fund positive, Nifty FII to mutual fund negative, they are moving opposite. and FI to mutual fund negative. So these two results are highly significant, which show you that the response is very, very high in first 5 days. It is very high in 5 days. You can see in up to 5 days, the response is very high. After that, it start declining, and within 10 days, around 11 days, the effect is dying. So you can find out the short-term and long-term effect of the impact. And in this case, these are the points where the after that the effect will die. So this is known as short-term response. After that, effect will die. Response period. Response period. After this response period, the effect will die. So you can study that in how many days the response of one market to the unexpected movement in the other market will die. So we can do a lot of study by looking at the impulse response function, which is one of the important output from a research paper using VAR. So finally, after looking at the short-term response, long-term response, or the type of response, if you click on simple, now the response is coming for only days. And in some papers, I have seen they reported only long-term response. Like in our paper, this is the VAR result, and we reported the long-term accumulated response. Because frankly speaking, the accumulated graphs are much beautiful, better as compared to simple graphs. So we prefer to use the accumulated graphs, accumulated impulse response function, looking better, giving more information, and that's why we go for accumulated responses like this. So after this impulse response function, which is one of the important part of the paper and gives you important results showing the causality by the graphical method. So they are very, very important. After that, once you finish the impulse response function, then the last, second last, you need to go for variance decomposition. So variance decomposition. So if you go to the variance decomposition, first of all, you have to click on the table. No standard error. We are having only one option, Cholesky decomposition. So here we cannot have any option of generalized impulses. Normally in research paper, they take 10 periods. And Cholesky ordering is this. None, and click OK. So now you will have this result. In order to explain, I am taking 5. Otherwise, in most of the research papers, I have seen 10, but all the table comes in one page. For that, I'm taking 5. So now, what is the meaning of that? Meaning of that, this meaning is, let's say mutual fund. So let's say mutual fund. The mutual funds, they 4% they are explained by Nifty. 0.42% they are explained by FII, and 94% they can be explained by own behavior. Similarly, foreign institutional investors, 6% by Nifty, 93% by their own behavior, and almost null, almost zero by mutual fund. Nifty 0.24 by FIIs, 0.3 by mutual fund, and 99% is unexplained. So how much one variable can be explained by other variable is represented by variance decomposition function. So I have seen variance decomposition in almost every paper which is using the VAR. And you can also go for the historical decomposition, or let me show any other thing. Yeah, combined graphs. So you have all these options also, stacked graphs. So you can report it, the variance decomposition by the graphs. But in research paper, I have not seen these graphs. I have seen only the tables. But whenever you are presenting in a research, in a conference or a PhD submission, you can include it, these graphs. So variance decomposition, combined graph. So combined graphs, or multiple graph, we will have the different graph in that case. Okay, this stacked graph is more attractive, especially when the variance decomposition is significant. And we also have some historical decomposition. So they don't have any meaning. So not very important. After doing all these things, in the research paper, you need to report the variance decomposition. It is one of the important output, variance decomposition analysis. And normally the 10 days we take to represent the variance decomposition. So I will give you this paper so that you can read paragraph wise. So we explain how we represent the variance decomposition. And after that, for a research paper, this much is enough. But when you are doing for the forecasting, the last concept is to forecast. After that, after doing all these things, you can go for representation. These are the forecasting equations which we have to use for the forecasting purpose. So you can make with the help of these equations, you can do the forecasting. For example, you can go to the forecast. You can go to the forecast. You can see the option, forecast option, and you can forecast any of the series. Dynamic forecast. If you want to go to dynamic forecast, you need to add the sample. So let me show you. We are having 4,617 observations. So go to prop. Let's say I'm doing 5,000. Need to add the samples to forecast. 383 observations I'm including. And now we are having 500 observations. After that, let me try to show you the forecast. So we have applied 5 and it is D. Yeah, normally we can do the 1 day forecasting because you must have the previous values of the Y. So if you do this, the software will give you the forecasted values. Like you can see the log Nifty F, FII F, mutual fund F. So these are the forecasting values of the series. So we are having the forecasted values up to 5,000 days. 5,000 days. Let me show you that because it is a log value. So I am taking Nifty equal to exponential of log Nifty. This is just like anti-log. And after that, I'm taking the I want to see the values of Nifty. So okay, the values are not coming. Yeah, so I did one mistake. Nifty equal to exponential log. I have to click on this log Nifty forecasted. So you can see the forecasted values of Nifty up to 5,000 days. So you can forecast the future values of Nifty also with the help of VAR. So this is the end step, last step of doing the forecasting. So we can do the forecasting with the help of this VAR also. Like we do forecasting in Arima, we can do the forecasting in VAR also. If I plot collectively, I can show you that this is the forecasted value according to the VAR model. This is the average forecasting value and this is the actual value. So we will assume that this is the time when software can go down and it is overvalued and it may approach to this value. So we can also do forecasting with the help of VAR. So that's it for today. And we have seen the example of a VAR with the help of this. Tomorrow I will continue the VAR, but by using the another example, and using the R. Because in R, we are having very strong codes to run the VAR system. So give me a minute.